so that I can know means how many of you have it installed, or so it will be good for me like to assign you some homework or assignments for that. So please tell me if you have Ansys installed or not. Just simply type yes or no, or else like you can also type like your laptop is not supporting or any other issues. Okay, I get a response from three, so they three are not having Ansys. Um, okay, five responses I got, and nobody of them has Ansys installed. So remaining seven. So sixth response not, seventh no. No, no, eight, nine. So still two are remaining. Three are remaining. Okay. I think nobody from our batch has Ansys installed. So anyway, then maybe in so you have to see her only in this session, and maybe you need to practice on maybe in the lab or somewhere in the college where you have these Ansys. So we can't do anything for this now. Anyway, so I'll just move forward with the problems from our session one. Maybe I'll simply share my screen. So let me know when you see it. So I will again go back to the assignment one. So I know like we have solved two problems on that day, and I asked you to solve third code, but unfortunately none of us has Ansys installed. So I think nothing to check the problem. So I'll simply what I'll do. I'll solve now problem three, four maybe. Let's see how it goes, and then we will start with the session number three today because we lost yesterday's day. So maybe I'll cover this second assignment, or maybe so maybe on later days. So from today I will start with session three, and I'll just try to complete some portion from this one because as you do not have the Ansys installed, so yeah, I'll carry out this. Okay, so let's start with problem three. But before going to that, I just want to recollectively maybe a summary of first session. I want to say what we saw in our last session. What is finite element analysis we saw. What is the difference between analytical, numerical, and experimental methods we saw. We have seen like what numerical methods are available to calculate a variety of real world problems, and even we have seen at the last like a difference between CAD module and CAE module, like 3D model, and what actually computer aided engineering is. So that's what overall we have seen, and afterwards we started with solving this problem. Now just I'll carry out this problem. Just have a look on that. Maybe uh, you can also, if you want to add, you can also add in between. So first of all, the normal process is just go on to the start menu, just put a workbench. So actually I'm having 18.1. Just click on that. When you click on that workbench, this window will pop up. So this we call it as project window. In that you have file, view, tool, units, extension, all these menus you have. So from that your first part should be just to check units. So I checked it, and I want it in metric. So I just selected in metric. But again, as I have seen kg, meter, second, so I want it in millimeter. So yeah, I just shifted it to this one because I want my lens or everything is in millimeters. So I just selected the other one in the metric form, right? So that's what, and now my window is ready to use as a template. Then I just double click on the static structural, or I just drag and drop it over here. So I will have one window over here. So which is nothing but my problem, whatever I'm having in my assignment. So there actually we have already seen we have three steps: pre-processing, processing, and post-processing. In pre-processing, I have to set up the material and I have to
Sir,
set up the geometry.
you are not present in
Yes,
screen.
please. Oh, sorry. Oops. Sorry. Oh, so from this point onward, if such thing happens, just let me know, please. Yeah. So now actually we have lost. Maybe I can repeat quickly what I just did. I did this. Let's see. What I did, first of all, I go. Now my screen is visible. Anybody can unmute and tell me. Uh, is it visible now? Yukesh, can you tell me, is it visible?
So I think no, sir.
No, sir.
No?
No, sir.
Let me share it again. Okay, now I guess it is.
Yes, sir.
Okay, perfect. Okay, then what I was saying, just to open the project window, just go on to the start menu, just type workbench. So you will have this workbench. So just click on that. Then you will have this project window, which will pop up. Here you have different menus, and this is file. So basically, it is for opening, saving. So general, like Word and Excel. Again, this is one important one, the units, because whenever you start it, your first job should be to set the units. So I already set it to so I want every dimension in So if I would do not, I just want to create my also, I can just go into the unit system and I can create my own also here. So you can simply go and check, and whatever you want in that category, you can set your units. But one thing you should keep in your mind, you should have uniform units throughout. Means maybe for this A1, I used millimeters. For B, I was using meter. And if I'm taking some data from this analysis and using this analysis, then it will be wrong, because here you have different units and here you have different units. So try to use same units. So don't just go sometimes with SI units and sometimes with maybe some different terminology, let's say GS or something like that. So your unit system should be uniform throughout your all calculations. Wherever you have the data transport, maybe from this A category, I'm just shifting some data to B1 in that case. So just this one thing, keep it in your mind. And yeah, now I just want to make a new calculation. So what I'll do, I'll simply double click on this static structure, or I can drag this and drop it over here. So with that, what I do, I just create one calculation system over here. So now it's D. So because I already have three created over here, so now it has become fourth one as a D. So I can rename it. Maybe I'll just rename it as a problem number 3, as we are solving from assignment 1. And I was telling, like, as we saw, like, we have three different steps in the calculation. One is pre-processing, second is processing, and third is post-processing, right? So in pre-processing, my second and third part will come. In second part, I have to define my material properties, which is nothing but engineering data. And this third row, I need to define my 3D model. So 3D model might be anything, like if I can create it using design modular or space claim. Otherwise, I can simply import the model created in SolidWorks, Creo, CATIA, or NX, any 3D modeling software. I can import it here. So that comes under the part of geometry. Third one is model. So where what I'll do, I will mesh and I will define some contacts. So that is nothing but in my processing part. So first two portions are in pre-processing. So now from fourth row onwards, I am in processing part. So in processing, first part is model where I'll mesh my model, and if there are some contacts, I will define those contacts. So that part will come in model. After that, in setup, I'll apply boundary conditions. So as we saw last time, I have applied some forces and fixed boundary conditions. So that is nothing but setup of my model. And in sixth row, it's solution. Simply, I'll right click and say solve. So that's nothing but my solution. So all these four, five, six, these steps come under the processing part. And the last one, seventh, results, it will come in post processing. So here what I'll do, I'll simply extract results for maybe equivalent stress, deformation. So those results I extract, that is nothing but my last step of my calculation, right? So I'll start here with the engineering data, but before going to that, I'll simply check the model for today. So here I have this hollow square tube having this much thickness, 2 millimeters, and I have again this beam of length 440 millimeters in x direction with the force of 4000 Newton, that too in positive y-axis direction. Okay, so here and again I am having material as a titanium alloy. So I'll go to the engineering data. Now I have to define the material as titanium alloy. So for that, here I'm having one menu, engineering data source. So whatever you see on the left side in the toolbox, all these are my material properties. These material properties are for different materials. So that material may be metal, that may be non-metal, maybe I am having some plasticity, some gasket, all these steps available over here, right? But from that, I have even Ansys have some defined library, defined material library for it. So I will simply click on this engineering data sources. Here you can see the Ansys library. So this is nothing but and everybody like who installs Ansys, they have these materials available with Ansys, right? So what I'll do, I'll just click on general materials. Again, here a lot of categories are there. You can see general, even non-linear general materials, explicit materials, hyperelastic. So those are basically rubber type materials, even thermal category materials, fluid materials. So that variety of materials we have. So currently we general materials. Again, in general materials, you can see there are the subtypes of those materials. So aluminum alloy, concrete, copper alloy, grey cast iron. So these are the all the general materials. I'll simply go to the non-linear. You can see all are non-linear materials. Stainless steel, NL means non-linear. Structural steel, non-linear, like that. So I am interested in now titanium alloy. So I'll just search over here whether it is available. Yes, here it is. So what I will do now, I'll just click on this plus symbol. So what it is saying, I'll just move the cursor to that plus, then it is saying add to D2, right? So I'll just simply make click on that plus symbol. You can see this like notebook like structure. It is saying that that material is added in my current library. So now what I will do, I'll again move back to my original page. So simply click on again to this engineering data source. So that window will be closed by clicking on the same stage engineering data source. So now I'm having, so this was a default material structural steel, and now I have defined as titanium alloy. I can check the material properties also. So very important properties which are required for finite element calculation are: first is density. You can note this down. So this is a very famous interview question. Means whenever you will face some interview in your future for maybe a finite element analysis domain, so this will be a very popular question in front of you. What material properties you need while solving the any numerical problem? So for them, so first property is density. So why density? Because this density defines weight of my material, right? That's why this density. And second important property is, so here in isotropic elasticity part. So if you are solving a simple structural problem, and you are interested in stresses and deformation, then the Young's modulus will be required. So this is must. And third part is Poisson's ratio. And if you are neglecting maybe self weight, then if you don't have density also, then it doesn't matter. So if it is zero also, then also it doesn't matter. But you should have this Young's modulus and this Poisson's ratio. These two parts are must in order to get equivalent stresses and deformations. Shortly, like strain. So whatever output is, like primary output of this calculation is stress, right? So Ansys calculates actually a strain, but strain and deformation. If I have a strain and deformation, I can simply calculate strain, because you know the famous relation between stress and strain, right? Can anybody tell me the relation between stress and strain? Maybe simply, what is the relation between stress and strain? Uh, I'll just go to the top. Yukesh, please unmute yourself, and I just want to have that relation between stress and strain. Maybe while talking, I already told that, but just I want to listen it from you. Or maybe you can tell me like Hooke's law or something like that. So everything, like anything you can tell. Absolutely free hand. Yukesh, please. Relation between stress and strain.
Sir, in Poisson's ratio, it is defined by lateral stress divided by lateral strain.
Oh, fine, fine. That's perfect. Actually, it is a Poisson's ratio. But I'm asking relation between stress and strain. You have that stress strain curve. In that, you have Hooke's law. So Hooke's law states a relation between stress and strain. Do you know that? Like maybe something proportionality. What is proportional to what?
Sir,
Huh? Please.
strain is directly proportional to the stress.
Absolutely fine. Perfect. Stress is directly proportional to strain. And my what is my like proportionality constant? It's nothing but my E. What is that E? So here we have, right? This is nothing but my E, right? Correct? Young's modulus, right? Or what you can say it like elasticity modulus. E is nothing but my elasticity modulus. So what it gives me, stress upon strain is equal to E. And this is my Hooke's law. So whenever my material is in elastic region, what is elastic region? When I stretch the material and when I just simply remove my load, then it will regain its size and shape, whatever original size and shape of that material. So that is my elastic, or I'll say proportionality limit. So this Hooke's law is applicable in that. And what is its application? Like stress is directly proportional to strain. Means whatever load I am applying, maybe I am applying 10 Newton, 100 Newton, 1000 Newton. So it will have that much strain in proportion. For 10 kilonewton, it will have some strain. For 100 kilonewton, it will have some strain. It's in like linear proportion, right? You understood now? That's why these properties are important while solving my any numerical problem by using computer or maybe any computer software. So Young's modulus, Poisson's ratio, and density. Okay, so you will face such question in future if you are going to for these domains some interviews. So this is base of all, right? So I have defined now these three material properties. I have this yield strength, compressive strength, ultimate strength. They are there just for our information, but they are not actually used in my calculation. For calculation, only these three whatever quantities I have told you. So those are only required, right? So we are over here. We have defined now titanium alloy. Now what I'll do, I'll again go back to my original project window. I can simply click on this project, or I can also just close this. I can go back to then my original project window. I can do it both way. So here I was. Now I have done with my second row. So I have defined the material. Now for geometry. Now I have again two ways. Just right click. I can open it in space claim. I can open it in design modular. Now I am preferring design modular. And in design modular, what I will do, either I can import any external 3D geometry available with me, maybe in PNG format, or I can create it by myself in this model. So this is very similar as next. This is very simple model. That's why I not prepare it in SolidWorks and just import it. So I can make it simply in 2-3 steps over here. That's why I'm just using design modeler. So I'll just go on one plane. So I just selected this XY plane. So there I will be having maybe before going to that, I just want to see it is in X. Here you can see this length is in X direction. So I just want to create line in this X axis. So after clicking on the plane, I'll go to the sketch mode. So I want my beam in X direction. That's why I have selected this XY plane, right? Then I'll just click on the line. So afterwards, what I did, I selected plane first, then I went on that sketching. And after sketching, I selected line. I just want to draw a line. Then I just simply move my cursor. When I just move my cursor on that point, there you can see it has mentioned some P. Maybe I can zoom it little bit. So there you can see some words are coming. These are nothing but constraints. So I just want to start my line from that point. So here when P appears, I will simply click, and then H means horizontal line. If I just drag it vertically, then it will give me V. You can make them off also. So constraints are there. You can just go into that setting and you can make that off if you want. You don't need these suggestions then. So, but now I need it. That's why I kept it as a default one. So I just mark again. C means what I will say the coincident point, or when my both lines are overlapping. So that's mean by C. So whenever that C comes, I'll simply click over there. Then I will have a smooth line having like my point from origin, and that line is based on my x-axis. Okay. Now I'll simply check the length of my beam. The length is 450 millimeters. Now I'll go into, so I was in draw menu now. I will go in dimensions. So by default, like general dimension, it is selected. So if I simply click on the line, it will give me this line. But we can just check other options also. What options are available? Just if you want to just come out from this window, just press escape. You will be back on your window. Then I will simply click it and press delete. Then it will go. I just want to show you other options. That's why I cut that line dimension. Again, I go to the horizontal one. So horizontal means what? So it will just give me these horizontal lines. In that case, I need to select these points. I will have that horizontal dimension. In case of vertical line, I can select vertical also. In case of some angular, like line is in at some angle, then in that case you can select this one. For circle, radius, diameter, angles, you can have this all dimension. Why I gave this dimension? Because I cannot simply drag this point. I can simply change the dimension length, then I will have exact whatever size of beam I want. Now here I can see I have this in meter, so I don't want it. I just go in units again. I set it to a millimeters. Now you will say me like at first we have changed the units, but when we change the units, those are in like this project window. Right now I am into the design modeler. So design modeler also has its own unit system. So there also I have to stick to the size. I want 440 millimeters length. So I just mark this as 40 millimeters. Now I have my beam created. Okay, so my first part is complete now. Now what I want to define such hollow tube having A, B, and T, these three dimensions. So Ansys has its own library of cross sections. So just go into the concept. From concept, you can go to the cross section, and there you have to search for hollow square tube. So here, rectangular tube. You have that. So there, just click on that. So that cross section has automatically been defined. So there you can see you have variety of dimensions. So basically I'm interested in this and the thickness. So you can see T1, T2, T3 and T4. All are the thickness at maybe one location, 2, 3, 4. So I just want uniform thickness throughout. I'll just go back and I'll check again. I want uniform thickness throughout. So it will be 2 millimeters. My horizontal length is A, which is 55. My vertical length is B, that is also 55. So it's very simple for me. I'll simply set 55 millimeters and check over here. Yeah, it has been defined as 55. Again, the part. So here I will define 2 millimeter. Same thing. Now you can see only this section has been made up of 2 millimeters, but others are still 1 millimeter. So what I will do, I'll make them also as 2 millimeters. Okay, now I have defined my cross section. I'll check it 55 by 55 and 2 millimeters thick. Right, now I have defined my cross section. Now I will again come back to my sketch. So here it's only line now. I have to define it as some beam part. So what I will do, I will again go to concept and I will select lines from sketches. Why I did this? Because I want to apply a cross section on this line. That's why I'm making this step. So in here, it is asking me base object. So base object is nothing but my this line. So where this line is stored on XY plane. So I'll just go on this sketch one. So sketch one is on XY plane. So I just select sketch one and say apply. So here one sketch, right? Afterwards I will say generate. Now you can see. So there you can also see one local coordinate system and that line. Fine. Now, and also you can see here part. So earlier, before this step, like before creating this line from the sketch, here 0 part 0 body was there. But as I did this, as I defined a line from that sketch, here actually one line body has come up. Right now, I have to define its cross section, which already I have added over here. And I can add number of cross sections over here. So I only added one. Maybe you can simply go on cross section again, go on concept again, same cross section. You can add n number of cross sections here. So concept, cross section, T section. So rectangular, channel, T. So whatever sections you want, you can add. Now go just onto our line body. And which cross section we want for our calculation now? The first one, rectangular tube, right? So I'll select it, right? Now I have that rectangular tube generated over here. And again, I have like multiple options. So offset type. So maybe centroid, shear center, origin, or maybe user defined. So what it will do by defining that, the centroid of this tube can shift wherever I want, maybe at this location, this location, this location, this location. You will ask me now, then why this is required? Why the centroid we need to shift? Maybe I can give you it one example. Suppose you have this beam, and maybe your beam has or maybe just consider this is one bridge, maybe over one any river, and on that bridge we have maybe a concrete road, right? Or maybe some like a footpath or pave blocks are there on that road. So it is adding some weight on that road, right? And if if I'm adding some weight at the top of that beam, then it's fine, like my centroid will shift towards the upward direction, because my weight, I'm just concentrating some weight at the top side. That's why that case is required whenever we have such scenarios. And yeah, in real life calculation this situation comes, but for now I'll just take it at a centroid one, right? Now, my geometric portion is complete. I can simply close this window also. Simply I can close it and I can move to the next step, model. I'll double click on this. So now I just double click on the model. So I'm entering into the processing step now. So I have completed my pre-processing. I'm entering into the processing part. So here my basic role is to mesh the model, and if there are some contacts, to define that context. So only these two steps are there, right? As here we have only one body, so no need to give some contacts. But in case like if I have more than one, two or three parts, in that case I need to define contacts, right? That we will see in our later sessions. So first, when I open it, then my first part should be just to check units. I go in units and check it. So yeah, they're in millimeter, kg, Newton. So what I want. So that's fine for me. Now I'll go to my second part, should be just to check the material. So I'll just go on this geometry and this line body, which is nothing but my part. And here in details window, I'll see what kind of material it has assigned. So material and assignment. So here you can see it is a structural steel. It's by default. Structural steel is a default material of Ansys. But I don't want structural steel. I want titanium alloy, which I have already defined. That's why it will come. If I haven't defined it earlier, then it wasn't come over here, right? As I have defined it earlier, so it is coming in this menu. So I simply click on titanium alloy and make this. And there is one more option. So here, if you click on geometry and just go on this display side, in display style, if you simply make it as material, then you can see here titanium alloy. If here I'm having two, three different materials, then it will show me with different colors, right? And you can just cross check this if you have applied a exact material to your body or not, right? Now we will move forward for meshing. So simply I'll right click and say generate mesh. So my mesh will be generated on this part. Now you can see after meshing, you can see the cross section, so which we have defined. So 55 by 55 millimeter length and 2 millimeter thickness, right? Now I'll check the loads. And one more thing, actually, whatever you are seeing over here, this is only for visualization purpose. So whatever we have modeled is simply a line, right? So whatever we have defined is coming from that line. So here, if I just go to the Z, and here from that, here also you can just see the shortcuts. If I'm clicking on this Z axis, then I can have this XY plane visible. If I click on X axis, then I have this YZ plane visible. And if my model has moved somewhere else, if I just click on this, maybe I just press F7 as a shortcut key, or directly click on this symbol zoom to fit, then my body will pop up again into my screen. So this symbol is very important. So it happens like your this part goes away from your screen. So just click F7 or click on this window. Now I'm interested in this window like XY. So whatever the points are, they are nodes, and whatever this one like single part, they are elements, right? Now what I need to do, my first part is, so just go back here, and I want to fix this point, 1 point in XYZ direction, and on this point I have to apply force in positive y-axis direction, 4000 Newton force. So first I will fix it. So just go on to the static structural, right click, insert, fix support. And what is it is asking me? It is asking me to select face. So you can see over here. So point, edge, and face. So currently this face has been selected. So wherever I will click, it will only detect the face. If I click on the edge, it will select edge. It will not check my points. But what I want a single point. So I just select this point. I'll click it over here and I'll say apply. So my fixed support has been applied to this point. Now I have to apply force. So I'll again go to the static structure, insert, and say force. Again, the same procedure. I'll check whether it is a face, edge, or point. I want it at a point. So select point, click it over, and say apply. Now I want my force in positive y direction and 4000 Newton. So instead of defined by vectors, I will set it to the components. So X, Y, Z component. And I want it in positive y-axis direction. So Y and that to positive and 4000. So you can see I have now 4000 Newton force defined on this point. And you just click on the static structural, you can see all the boundary conditions you have applied. Like A means blue color shows that here I am having fixed support. B means red color, it shows that force. So here I am having force, that to in vertically upward direction, that arrow shows. Right. So now I'm done with my application of boundary conditions. Now I can simply right click and solve it. But before going towards solving, I have told you the very important step during our session one. What results I want? What I want over here? I want here deformation and stress. Which stress? Equivalent stress. So these two results I want. So for that, I just need, maybe I just go to analysis settings and I check. So here also, yeah, in the solution, I want post processing for beam sections. So if I just say it as no, then I will not have the equivalent stress results after I solve it. So you know the meaning of this, like beam section results means equivalent stresses, those are calculated on my beam section. If I make it no and solve it, then I will not get equivalent stresses, because the stresses are, I'm saying here, don't calculate it, and I'm solving it. But if I just make it S, then all the properties for this section are calculated. So I make it S, just simply right click and say solve, or just hit F5 shortcut, then it will simply solve for us. So now we just need to wait when until it gets completed. Yeah, now my solve has complete. And here also you can see, just click on solution. It will show you what time it has required, what memory it has used on your D drive. So everything it will show you over here, right? And even you can go to the solution information, and here you have multiple options, solver output, as we have only one body over here. So other options are not available now. And in this solver output file, you can see all the details basically. uh, After some time, when you will become expert in this domain, after that, by simply seeing this file, this you can simply select and save in Word format also. So by seeing this file only, you can simply tell like what properties you have used, what loads you have used. So this is nothing but some summary of your analysis. So this is the best way to check whether you have done your analysis correctly or not. So these files even indicates you some errors also. Maybe sometimes if you come across any error during your calculation, so this file only, this solution output file only will tell you what errors you have and what you need to do just to overcome that error. So this is very important file. But now I will not go in this file in depth. So if you are interested, you can simply check this file. And if you just come across any questions, you can ask me anytime, right? So this is very important file actually. Now I'll just check what results I want. So one is stress and second is a deformation. So again, same thing on solution. I'll say insert in stress. I'll insert equivalent stress. Or I have also shown you the second option to insert the same thing. Just here you can see solution and various options available. From that, stress, equivalent stress. You can also do it from here, right? Now second one is deformation. I want deformation, so go on to the deformation. And I'll say directional deformation. And which direction? Y direction, because I have applied force in Y direction. So simply in this drop down, I will select Y axis. Again, right click and evaluate. So for by this force, my beam, it is deforming in upward direction. Here I am having fixed support, and this is nothing but a cantilever beam. So it has highest deformation at this point. So here basically blue color you can see 0 millimeter to 0.69 millimeter. So this range has been shown by dark blue color. So here, so whatever coming in this color is in between 0 and 0.69. Same thing for red color. What is in red is from 5.53 to 6.22. So what is coming into this red color from this range, right? So these colors actually gives you the range. And if you want exact value, you can simply go to the probe and you can just place probe at some of the points. Maybe here, if I place it here, I can get 6.2019. I can right click, drag, it will zoom for me. I can take it over here, here, anywhere if you want. Anywhere you can take it. So maybe if somebody wants to check it at this, so you can see the point like raised to -4 means this is almost 0, right? So maybe I can just rotate it, and if I want to check it on these faces, because we have applied boundary condition on this face, so you can see everywhere it is 0. And I just selected the point. This is slightly apart from that edge, that face, so which is having almost near to 0, like 10 raised to -4. Right, so these are the results. Again, same thing I'll do for my equivalent stress. Here I can see. And yeah, maybe I'll go to one more point today, these results. So here you have options to maybe play with your results. So I'll go with undeformed first. So you can see you have your original model with only difference in color now. So undeformed. So whatever load you applied, I don't care. I'll give you the same results what you have. Like I'll give you same geometry results. So that's nothing but undeformed. Second is true scale. So true scale means whatever values are present over here, according to that my model will look. So this is nothing but true scale. And again, I have some factors applied to that. So factors applied to my true scale. maybe 1.8. So whatever value is there here, 243. So 243 into this 1.8. So whatever will come will be shown over here. So this is only for visualization purpose. So this is only for my visualization purpose. By this, what I comes to know, my beam is deforming in this direction. Here actually my deform or my stresses, they are maybe comparable. So you can see by your eyes, but in some cases they are very very small. So you cannot simply see the stresses or deformations in the model. That's why this menu is required, just to scale up just for your visualization purpose. And again, you have option over here in the graph part. Maybe I can simply move this to this location here. Yeah, in the graph portion, you have one option. It will give you an animation. So maybe I'll simply click on this play button. So this will give you an animation, so how it is going. So just keep your eye on this time. So what time I have, like 0 to 1. Maybe if I just go to the 4, have any load, and second is my one time. So at that time I'm having 4,000 Newton load. So if I just go onto the results, and if I click on the animation, you can see from 0 to 1 how my beam is deforming and what is the impact of this. Basically I'll say the factor which I have applied. If I just go on to the undeformed, you can see, so only color will change, but I will not get idea like in which direction my beam is deforming or what, right? So that's why this is important. If you need to present your results to somebody, or from in your thesis you need to present this, so this is very important tool. Again, here you can view your results. Maybe if I just tick exterior iso surface, then you just see surfaces. Even capped iso surfaces, you can see capped surfaces. So here also, like you can select the value. Maybe deformation is up to 6.6, but I just want to see deformations which are above 4. So I will simply enter here 4, and I will see. So now it has selected below 4. What I want to see, bottom capped isosurfaces. So whatever results above 4, I'll click this one. So this portion is having deformation more than 4 millimeter. If I click here, then this section is below 4 millimeter deformation, right? And if I just click on this one, so it will show me the boundary at 4 millimeter. Means this boundary, like right side of it is having 4 millimeter deformation, and left side is having less than 4 millimeter deformation. So this is the use of this one. Again, I go to exterior, and here one more menu here, just to show whether you want results in like mesh format, or you want just a line body, that to deformed plus undeformed, or you want wireframe. So these are multiple results. You can try it when you just come up with this calculation. Just check all the results. So these are important while you prepare your results. So in results, if you want to showcase this one, so these are very important. Like this was my undeformed shape, and after deforming, it became like this. Okay. Again, max and mean. Here, if you just click on max, it will show me where the maximum value of my deformation is. If you click on mean, then it will show me where my minimum value is. And I have already told you the probe, wherever I will click, it will give me the value at that point, right? So now here we have completed the third problem from session 1. Now I think I'll start with the session 3 directly, and skip session 2 for time. Let's cover 2 afterwards. Now you can see we have covered 3 problems, and these problems maybe they are for your assignments, because they are all similar. So only difference in between those is in design modeler. Maybe I will quickly go to the design modeler again. Now you have seen, like I have only double clicked it, because I already opted for design modular. I haven't opted for space plane. So when I simply make it and save it, so afterwards I don't need to select it every time. I just need to double click it, right? So I go to design modeler. So only change is in this cross section. So only you need to add these different cross sections, right? So this is only difference, and all other steps are same. So that you can always try with these problems. So now coming on to the assignment number 3. So from assignment number 3, I'll check. Okay. So now we have seen 1D models. Whatever models we had, they were of a simple line. So in Ansys we have 1D, 2D, 3D. Those are my elements. So 1D basically means my beam element. 2D is nothing but my surface body. Whatever surface I'm having, so I call it as like a shell element. And in case of 3D, I call it as a solid element. So we will simply now moving forward with our assignment 3. That is nothing but with my solid elements, right? So here we have one, two, three, four types of problems. So we will go to them one by one today. Maybe I'll save this one and I will close it. Now, for assignment number 3, I like to make a new file again. I'll go to the workbench from start menu. Uh, Now, I just want somebody of you to guide me to prepare the model. Maybe first steps are common to this also. So maybe I'll choose randomly one from this. Uh, to this guy. I can't see the name actually. Oh, here it is. Can you tell me like which steps should I follow? So please unmute yourself. 20G110. I can't see name. Sorry for that. But yeah. Uh, I can't even unmute from my side. So please unmute yourself. Yeah, here. Vimal Raj. Here I can see your name. Okay, Vimal Raj, please unmute yourself and guide me to proceed with this. So now I am into my project window. Now what I have to do? Sorry, I'm not getting your voice, Vimal Raj. Please unmute yourself.
Sir,
Okay.
we should create a model first, sir.
Okay, I should create a model first. Before that, I need to define what calculations I need, right? So static structural. So how I can bring this static structural to this side?
Double click, sir.
Okay, perfect. Just double click or drag and drop. So I simply double click it. I'll rename this it as problem number 1. Okay. Now, what is my first part should be? What I should do now?
Create a geometry.
No, no, no. Before creating geometry, I told you I need to define my materials. Right here you can see problem statement. My first data is of materials, right? So
Yes,
my
sir.
first part always should be creating or defining my materials. So where I can define my materials?
Engineering data, sir.
Perfect, perfect. And engineering data. So this is structural steel, which is by default. So I do not need to define it again. So it is already there, right? So my first part is completed by Ansys itself by giving the static structural as my default material, right? Structural steel, sorry. Now my second part should be creating a 3D model. So I told you like how I can open it in 2 ways. So you can tell me like how I can do it over here.
Double click, sir.
Double click. Oh no. So I'm opening it first time now. So if I double click it, it might open in Space Claim. I don't know, or it might open in Design Modular. So I told you just right click over it and select in which menu you need to open it. If maybe if I would have double clicked it, it would have opened in this space claim, but I don't want it. I want it in design modeler. So simply right click it in, open it one time, like one time if you open and close also, but afterwards by double clicking, you can directly enter it here in design modeler. Fine. Now what I need to do, I already told you there are two ways. Either I can create a geometry over here, or I can import any other geometry created in any other software like SolidWorks, CATIA, etc., etc. So I'll show you here the second option, right? Thank you. I forgot the name. Uh, Thank you, Vimal Raj. Thank you
Yes,
for
sir. Thank
you just guided me. Thanks for that. Now, what I will do, I will import the model created in other software. So for that, I have option over here. But before going to that, I just select any plane, maybe X, Y, Y, Z, or ZX, any plane. I just click on that. So on that plane, my model will be imported. So then I'll go to the file and I'll simply say, so here a lot of options are there like save, save as, even export, attach. So here I just want to import external geometry file. So I click on this. So after clicking on this, so I just go on where my file is saved. So I just randomly go on any locations. So I know where my actually all the files are stored. So I'll go into the that files location. So currently we are in assignment 3. So these are all 3D files I have. Now from that, which model I am having? So this is nothing but a round stool. So this is maybe I will say a quarter portion of full stool. So only 25% of model we have created. So I'll simply go to this tool and say open. So now I have done that with import, but my tool is not yet visible in my window. So for that, what I need to do, I need to say generate. Right now it is visible. So what I did now, I just imported the external geometry file, which is already saved in my PC. Little bit, or if you say I just make it top way, you can see this is only a quarter portion, maybe 25% of whole stool. If you just make it full one, then it will be round and smooth like that. Here also again I have both options. I can simply go with a 360 portion of stool. I can go with this 90-degree portion of stool or 180-degree portion of stool. Why I chose to go with this quarter portion? Because to save a time, if I go with maybe 180 or 360-degree model, here my solving time will go on. So because afterwards I will mesh this, right? And if I mesh this, there will be number of nodes and elements. And if I use the full model, then count of that nodes and elements will go on. And basically our numerical method is calculating my results over all the nodes. That's why my calculation time will increase if my node count is increasing. So to avoid that, what I'm doing, I'm just considering a quarter model, and whatever results I get on this model, my results will be similar throughout my 360 degree of my model, right? That's why I'm selecting just some portion of my full model, right? Now I think in geometry I'm done. Now I just need to go ahead with my model preparation now, right? So here I think only new concept is in element size during meshing. We will see it. Now I just go into the model. I will simply double click in this region or right click or edit. So both ways will open my mechanical window. So I am into the mechanical window now. So it is at my geometry. Fine. So here I am having my geometry. So here my first part always should be to check units. So what units I want, let's go and check in my problem. So this I want in MPa, this I want in millimeters. So I just go to the metric unit, go to the unit, millimeter, Newton. Fine. MPa is nothing but Newton per millimeter square. Right. So I just selected the units, and again second part always should be to check the materials. So here by default they have applied structural steel, and that's what I want. So I won't change this material. I will move to the next step, meshing. So last time what I did, I simply right click on this mesh part and say generate mesh. But here what I want element size should be controlled one, and it is user defined one. So I should define what my element size is. So now in meshing, I have two categories. One is global mesh and second is local mesh. So just for time being, keep this in mind, global and local. If I am having maybe 10 or 15 parts in this window like this, so this is my one part. So if I am having such 10 parts available in my window, then what I will do, I will right click, I'll say insert and I'll say sizing. So maybe here if I go and I'll simply select the body. So instead of face, I select the body and say apply. So this is my one sizing. And if I am having any other body, I will do same thing. I will say insert, say sizing. So that will be my other size. So it is called as local sizing. But now I'm having only one part or one body for my calculation. So what I will do in meshing itself, here I have option of sizing. So same thing I was doing like previously by insert and sizing only. And here also I'm having that option available, sizing and element size. So what size I want? 5 millimeters. Let's check it. So I want element to be of size 5 millimeter. This is nothing but my global sizing. If I make 5 millimeters here, and if I'm having like 10 numbers of bodies, then all my 10 bodies will meshed with this, right? And if I mentioned anything over, just simply add, insert, add any sizing. And if I put again 3 millimeters here, then my sizes will be different. So this is nothing but currently I don't rely on this global one, 5 mesh. So you can see a smooth and very nice mesh, right? All the elements are of size 5 millimeters. You can check that also. So here you have one ruler. Here you can check that also. So here you have one ruler. So here you can click any node and any adjacent node to check the distance between these two. So here you have one detailed window of section information. It's 5 millimeters. It is defined during this stage 5 millimeters. So my so now what should be defining the boundary conditions. Now see over here. Let us assume that someone is sitting on this tool. So maybe it is creating some force or maybe some pressure if it is uniform one. So maybe here we have 10 MPa as a pressure on this top face, whole face, and the bottom face, it is actually resting on my ground. That's why I can say my bottom face is fixed one, right? So I will go again here. So what actually I want? I want this face. So I just go on this face selection. I want this face should be exposed to 10 megapascal pressure, and this face should be fixed, means my stool is placed on my ground. So I'll go to insert and say pressure. So in pressure, I want pressure to be applied on this face. And what is the value of that pressure? Here I can apply as 10 MPa, right? So I have applied the pressure. Now I want to apply a fixed support. Again, go right click, go to insert and say fixed support. And I will apply fixed support from the bottom side, bottom face basically. I select face from this menu like point, edge, face and body. I want it to be applied on this face. So now I have applied my boundary condition. Just cross check. I will click on this structural. I have both the boundary conditions. So red is my pressure. It is correct. Blue is the fixed support bottom of it. It's correct. Now the boundary conditions. Right. Now the next part should be solid. Click here. I will not say be results because I do not need being clear. What is the last it was a beam. I want I made this as and exactly and here it has been solved in 4 it would yeah point is Hello, am I audible to all? Anybody can tell, or you can just text me in the chat. Am I audible?
Yes, sir.
And you can see my screen, right? Okay, okay. Sorry for the interruption, network interruption. Mm, so I was here, right? I was explaining about directional deformation, right? I was explaining directional deformation, correct? Can anybody tell me? So where we left? So I wasn't sure. Prakash.
Yes, sir. Yes, sir.
Surya, okay, fine. So I was just explaining the directional deformation. You can see in y-axis direction I have selected because I have applied pressure in y-axis. So I can see my deformation is maximum in this region, which is shown by red
Yes,
color,
sir.
and it is minimum in this region. You can see here the symbols also, like they are negative in sign, and maximum they are to positive in sign. Because now you will say me like, how come the deformation is in negative? It's just the symbolic representation. Maybe I'm having y in upward direction, so what it indicates, whatever is in upward direction is positive, and whatever coming like below this axis, like z axis in downward direction, is negative. If I am having this tool deforming in negative direction, that's why it is giving me just sign in
Negative.
negative one. But practically my deformation is always a positive digit. Maybe if you see over here the example 0.33 millimeters, so it should not be a negative one, it is always a positive number, right? Now here we have done one additional thing as a total deformation. uh, can anybody tell me what is mean by total deformation? So I doubt actually if you know this terminology, but if anybody of you knows this, so you can tell me what is the total deformation means.
So the complete deformation in the body,
Complete means what, in what sense?
the every parts we can able to see the deformation.
Yeah, you are partially correct, but not fully. I can explain you like what actually this total deformation means. Total deformation means here you can see I have three directions: x, y, and z. So three directions I have. In x direction, it is in y direction or in z direction. So here it will give me in total results. So whatever resultant of all three, right? Which is nothing but the total deformation. Same thing is about the equivalent stress. If you go or if you read some theory about this equivalent indication of I'll not simply say a resultant, but there is one very famous formula given by von Mises. So it indicates some representation or some algebraic representation of x, y, z direction stresses. And what we call these stresses as principal stresses, means stresses in one particular direction, we call them as principal stresses. So equivalent stress is nothing but representation of stresses in x, y, z directions. Right. Similarly, the total deformation. Understood? So connect my charger. Just one moment. Okay, done. So now it's clear what is total deformation is, right? So at some point you just want to see this deformation, and again, like I suggest every time when you just solve your model, just go into the deformation results, make this as like a model with deformation or undeformation, anything if you want. And what you do, I will select with some edges and just see exploded view of it, maybe 48 or 24 or 12 times. This is 12 times actual one. So this deformation you can see 0.07. You cannot even see with your eyes. That's why I need this big factor, like 24 times actuals, right? And just see the exploded view, how it is behaving. Maybe you can see it in different direction. So from here you can get a glance, means you can come to know how actually my body is deforming or how my body is behaving under this kind of load. You can see, have you imagined ever like when you sit on any stool, so this stool behaves in such a way. Means in reality also you can just correlate these things. So this is actually basically happening in my structure. Here actually this is very scaled up view. If I just go to the true view, you can't even, I guess, see the deformation. So but this is happening at micro level, right? So yes, hence we have completed the first problem. Maybe we will move forward with the second one because of the time constraints for today. So I will go with the second problem for today. Same thing again, things we do. But now I want somebody to guide me again for the second problem. I just untag this one. Maybe I'll tag somebody else from this. Let's see who will be. Maybe yes, this guy. Now I can. Oh, here I cannot see the name. Maybe you can simply unmute yourself. No, 0852048. You can simply unmute yourself and guide me for the next. Yes, or somebody else if you want to guide me for the next problem. Yourself, please. I cannot unpin this guy. Oh, here it is possible. So I just want to, yes. Can you guide me? Okay, so yeah, here I am, and I am into the. So this is nothing but maybe the cylinder, gas cylinder in our homes. So this is similar thing like that. So pressurized tank having maybe a cylindrical and elliptical head shape, having structural steel as a material. And here I don't have any element size preference. So whatever default should be is okay for me. My internal gas pressure should be 10 MPa, and constraint should be my faces, like bottom faces, right? And I want result in the form of equivalent stresses and deformations, right? Now, please guide me how I should proceed from here. So I will make in the same window now. I will make the different calculation. So from where I should start?
So from statics.
Okay, static structure. Very good, very good. So double click on static structure. Okay, so I'll simply rename this as problem number 2. Right now, now you see my first data is about my material.
Engineering.
Right. So already defined by Ansys, so no need to define it again. So I'll simply go back to my menu. Right now, I will see. Now what I have to do? So
I
my
think one
engineering
second
data,
up.
it has been defined. Second step.
So in geometry, you have to write.
Okay, in geometry, I have to right click and what I have to select? Hmm?
Second option, new design mode.
Okay, second, perfect. Design modeler, yes. Design modeler I have to select. So now my design modeler window, it's popping up. Now,
So right now we have to sketch now.
okay, okay. So now I want to import the 3D model saved in my local drive. So how I can import it? So we just saw it in the earlier problem. How I can import it? I guess from here somewhere.
So file and import external geometry.
Okay, fine, fine, perfect, genius. So from here, I'll simply select it to the assignment number 3 we have, and in assignment number 3, we have the container, right? This is the gas container. And now, what I have to do, I can't see that over here in my window.
Generate.
Fine, perfect. So here I have, again, I have the very small portion of my 360 model. Again, same thing, just to save time and efforts required. Okay, now I think I'm done for the geometry. Now what should I do?
So model, sir. Model.
Okay, now I have set up my geometry. Now I have to enter in model. So I need to just double click on model, and I need to open the mechanical window where I will define my boundary conditions, right? Okay, so now here I am. So my first step always should be to check units, right? So I'll check my unit. Yes, I have the same units, millimeter and kg form. That's fine for me. Now, what input says the element size is default. So I will go to the mesh. I don't change anything here. I don't apply any sizing, global or local, nothing I will do. I will simply right click and say generate, and whatever default mesh will be generated, it will be acceptable for me as per my problem statement, right? So now you need to help me again while applying this. So this is my internal pressure during its working. Now, what is meant by internal pressure and where I should apply that pressure? So this is my cylinder. This is my inner part, this is my outer part. So where should I apply my pressure and how should I apply that pressure?
So at the inner point,
Okay, inner part. So shall I select the edges or these edges? What should I select? Or shall I select the
Surface,
points?
sir.
first.
Oh, perfect, perfect. You need to select surface because you have to apply the pressure and pressure should be applied on the surfaces, right? Simply I'll right click and say pressure, and it's 10 megapascal, right? So I have applied the pressure. So first boundary condition I have applied. Now second one is the constraint is nothing but the fixity, means fixed support at the bottom location. So you can see from here it is saying bottom face, right? So again I'll do same thing. I'll go to the fixed support and say this face should be fixed one, right? Now what I need to do, I am done with the application of boundary conditions, means my this part of modeling is complete. Modeling even setup part is complete. Now what should I do? Here it is. Now what is my next step should be?
So you have to go with the solution right now.
Yeah. Okay, go into the solution and
So check
I
deformation, sir.
guess no, but before that I need to solve it first, right? I haven't yet solved it. So I have to solve it. So I said like I can do it by two ways. Maybe right click and say solve or press F5 simply as a shortcut key, or I can go from here also. Here also I'm having solve. If I click on it, so it's getting solved. So this is solving step, right? So from here, the solution is nothing but solving step. Yes, please go on. So this might be a last
Sir,
question
above
for you.
system.
So this one, this menu.
Yes, sir. Stress
Okay,
in that
from
equalization.
okay, perfect, perfect. So that is stress, and second is deformation. So deformation. Now I will select a total deformation because I have applied pressure in all the directions basically X, Y, Z. So it's like in isometric form I have applied. That's why now I'm interested in total deformation instead of directional deformation, right? Then I will simply right click and say evaluate. I will get this nice results. Got it. Uh, Maybe I will simply take one or two questions. If anybody has any question, he can unmute or she can unmute herself and ask at this point. Anybody has any question? You can raise your hand. You can see here something is like raise hand. You can simply raise your hand. I can ask you then. If, or anybody has any question or any doubt related to whatever we have seen today. Hmm? Yeah, I guess then nobody has raised the hand. I guess like it is understood. Hmm? Okay, then that's fine. I'll go to the third problem then. So two problems we have solved. Maybe I'll skip this third one. This looks little simple for me. I'll go to this fourth problem. This is axisymmetric analysis on a bottle. So this is nothing but our day-to-day life use product. We use such bottles in our day-to-day life. So we will try to have this analysis. Maybe you would have known the famous cold drinks of like Thumbs Up or Coke, something like that. So there we have such kind of things, and there we have this much pressure also available in that bottles, right? Or maybe some soda bottles like that. So they also has this much pressure on that those bottles. So yeah, we will solve this now. Again, here input data, I'll just read it out. So material should be structural steel. So I do not need to take much efforts because I already have this material defined as a default in my material library. Second is element size. So this is very important. Here I have to define my element size. That too, this is global sizing and it is 1 millimeters, and that I have to define. Again, same thing, pressure acting on cold drink bottle is like due to cold drink. So maybe this is only for this inner faces. So that is 10 megapascal. Again, constraint I have that from bottom face. So my bottom face, it should be fixed. And again, same thing in output, I want equivalent stresses and deformations, right? So now again, I want somebody to guide me for this. So this might be our last problem for today. So I'll select now the last candidate from the row. I'll see if I can pin him. So 21084.
So yes, sir.
Okay. Okay, fine. So please guide me like to solve this problem. So back to the main video. Okay. So can you guide me like from where I can start now? So I'll simply create one problem, more problem in this window.
So first select that static structural.
Okay, static structural. Just drag and drop or double click. Fine. So I'll quickly rename this as problem number 4. Okay, done. Now, now my second step should be,
So next we have to select the material in engineering data, sir.
okay, so as we already said, we already have that defined material, the default one, structural steel. Same material I have. That's why I will not go in this material library again, and I will not see for these materials. We define because I already defined.
Next we enter into geometry and start to doing sketches, sir. We right click on it and
Okay, I'll
select your new
now
design.
new design modeler geometry. Yes, I will go in design modeler, and I'll just wait here just to when my design gets open. And yeah, I'll simply now what I need to do to in order to import the external geometry file.
You have to select the axis.
Okay, basically we have to select any plane. So on that plane, it will come up, and then
Start doing sketches, that water bottle sketch.
okay, from files and import external geometry file, and I want now it to be for bottle. So pressurized bottle, here it is, bottle. So I'll simply say open. So in order to see my bottle in this window, what I need to do,
Generate, sir.
so my next, okay, fine, perfect, nice, very nice. So here I'm having my bottle. So if I just want to look at it with maybe different version, maybe in view, you have a variety of options like shaded exterior, or maybe don't want to see this frozen size. So you the exact model color. So like that variety of options are there you are viewing, right? So I'll again go back to the same one, whatever we had earlier. The geometry now. So now my next step should be,
Next we have to model it.
okay, perfect. Now I need to enter in my model. So I'll simply double click on this so that my mechanical window will open. I'll click close the some earlier calculations so that my these calculations will be a little bit faster because I have limited RAM. Okay, my mechanical window has been open now. Now I'll go up into the mechanics, which is not 1 millimeter. Because yeah, I first is to have a default material, right? So now I need to define the mesh size.
So what's the
Mesh size, like 1 millimeter, I have to define element size. So from where I can define it? At 1 millimeter. So global meshing we were talking. So from where, from which menu I can define that? The 1 millimeter size. So earlier, like we have defined 5 millimeters for that stool. So maybe somewhere in this meshing, somewhere here, it's nothing but my element
At
size.
the reference,
Sorry, can you come up again? I haven't actually heard your voice clearly. Can you come up again?
sir, at mesh, sir.
Okay, at mesh and in mesh sizing, right?
Sizing.
Yes, perfect. In sizing, I have option of element size. So instead of default, I just need to define it as 1 millimeter. I will simply make it as 1 millimeter. Fine. So now it is 1 millimeter. So I'll simply right click and say generate mesh. So my mesh is defined. So this is 1 millimeter element size. Maybe if I simply check by using these nodes, I can see this is 1 millimeter, right? Which is nothing but my element size. Fine. So now I'll again go back to my problem statement and see. Now I have to apply these two boundary conditions. One is pressure and second is my fixed support or constraint. So first part is application of pressure. So as I already told you, our pressure should be from inside, right? So this is nothing but my pressure having 10 megapascal. And second is constraint. So constraint actually I need to apply on the bottom face. You can do it either way. You can first select the face and say just insert and afterwards fix support. It will automatically take it. Otherwise, you can insert fix support and here also from apply. If you click it and say apply, then also it will be selected. By both ways, you can do it. I will delete the second one. So I have applied fix support, right? So I'm done with my boundary condition applications now. Now what I have to do, now you have to guide me from here. Now what I have to do in order to get the results. What should be my next step?
Next, we have to apply the pressure at the inner surface.
Pressure we already applied, na? Yeah, here. We have applied pressure, right? 10 megapascals I have defined also.
So next, we have to solve the solution.
Okay. I just go to the solution. I can solve it from this also, or I can just simply hit F5, or I can right click and say solve. By these ways, I can solve it. So I simply solve it, and yeah, after solving now I want it's two post processing. In post processing, I want two results. One is equivalent stress, and one is deformation. By default, total deformation I want. So how I can get that deformation and equivalent stress? I get these results. Yes, I think you are mute. You were telling, but we are not able to. Yeah, kindly unmute and say. Now, how should I get the equivalent stress?
So next, we have to check the deformation.
Okay, but how? From where I can get results? So it is from somewhere here. I right click, and if I say insert, there are other options which are shown here in the top. Current stress. From here also I can apply. So I'll right click. Insert and say total deformation at each step, and thank you for guiding me. So I just right click and say evaluate, and I just say I don't want
You
to
have
see.
chosen directional deformation, sir.
Okay, I'll select deformation and go say total deformation. Thank you for correcting me. So this is my total deformation. So what I did, I simply switched to the wireframe view. So earlier I had, like, by default I was having this elemental view, means here my elements were shown, but I don't want to see that element. I just want to see the wireframe. It will be very good for maybe a report aspect. So in report, this will give me clear cut idea about my stresses and deformations. So yeah, that way you can change it from this side. Okay, so this is nothing but my equivalent stress. Again, the maximum, if I click, so I can say maximum at this one of the edges. And if I just select the minimum, then I can see minimum is at some of this top location, right? Again, same thing I'll do for the total deformation. So again, maximum deformation is at the top location and minimum is at this bottom side, because we have fixity over here in this region. That's why we have the minimum deformation, which is nothing but 0 millimeters in this region, right? Then yeah, I think we have solved the fourth problem. So only this one is remaining. Maybe if you want, I can solve it quickly for you. Or if you want to try by yourself whenever you will have the Ansys license with you, you can also solve. But maybe I can say, as we have that structural steel, I will simply add it. I will do it quickly. So I will not explain now. Maybe I will do it quickly. I will simply double click there. Right, it has been added over here. So I will say problem number 3_3. I will go to the geometry. I'll say new design modeler. I'll select a plane. I'll say import, and it's something a step shaft. Right, I'll say generate. So my step shaft, it is visible in my window. Now I'll double click to the model so that I can open the mechanical window. So this will be a faster, because you are now familiar with all the steps. So that's why I'm moving in a faster manner. So this is the step shaft, and now I'll simply check the fixity. So top outer face and is having a pressure of 10 megapascal, and bottom face is having a fixity, right? Due to the bearing on top outer face. This is nothing but stepped shaft like this, mounted on one of the bearing over here. That's why I'm having pressure from this side, and shaft is fixed basically from this region. So maybe it has been horizontally or vertically supported on any axial bearing, like that. The scenario should be. So what I will do, as I have structural steel, so no need to check materials again. I have already set the units to millimeters, so no need to check it again. So mesh is default one, so just right click and mesh it. Now I have to apply the pressure at the bearing location. So there I have a 10 megapascal pressure, and second one is constraint. I have to apply a fixed support at my bottom face. Fine. Now I just need to solve it. So it has been solved for this case. Now I have to add my results. So from the top menu, I will select now equivalent stresses and deformation. Now I will select total deformation and even directional deformation, as I'm having this as a shaft. Maybe I'm interested in the shaft axis deformation, maybe y direction, because axial deformations I just need to check. Right click and evaluate. So this is total deformation. It is clearly saying my shaft is little bit bending in this direction. Even equivalent stress, they are maximum at this location. I can simply say max mean, so I can get out the pointers. And even directional deformation, you can see in this direction I'm having uniform loads. Like here also I'm having red region, here also I'm having red region, but deformation is 0.2 millimeters, so very small deformation. So yeah, that's it. We have solved now problems from assignment number 3. All the problems we have solved. So if anybody has any question, they can come up and ask freely now. So now I want everybody to unmute themselves if possible. If not, then if those who are having any questions, those can ask me right away. So yeah, I can solve all your doubts for next 4 5 minutes. If you have any questions, you can ask me now. So yes, please go on.
Sir, whether you will give the model for import or we will.
Yes, I can give that models also. I can ask Ajay. He can share the models available with me. He can share with you.
Okay, sir.
I'll ask him to share the model files also with you. Or I guess you already have the session of SolidWorks also, right? So I'll suggest you just prepare these models in SolidWorks because you will have that hands-on also on SolidWorks. But yeah, surely I'll take this question and I'll request Ajay to share these model files also with you.
Okay, sir. But without any dimensions, we can't do models. So only I ask, sir.
Okay, fine. No issues. I'll ask him to share models.
Yes, sir.
Any other question? Any other questions related to today's session or maybe session number 1? You can compare, like in session number 1, we have created the beams, that too in design modeler, by creating a line. In today's session, we have imported the external 3D geometry and we have meshed it. So that was the basic difference between first session and this session. In first session, we deal with 1D element, like one dimension element, that was line or beam. And today we deal with 3-dimensional element. We have seen today the total deformation, that too in 3 direction, right? So anybody has any question, please, we have a couple of minutes still. If you have any question, you can ask me. Or maybe if you go through this, just answer me. Ajay already sent you these files, like problem statements already, they are with you, right? So whatever these assignments it is with you.
Sure.
Okay. So anybody has any question? Please ask. So meanwhile, I will simply check what is there for us tomorrow. Oh, very nice, buckling. So whatever we will see tomorrow, which it will be helpful for like heavy towers, a great like which is having very huge height. Such structures we will be seeing. So there where we will have the buckling, importance of buckling, maybe radio towers like that, which is having very big height as compared to its thickness or width or something like that. So such structures we will be seeing tomorrow, even spring-like structures. Wow. So yeah, tomorrow's session will be very important. So these are really real world problems, so which we will be solving tomorrow. So don't miss actually tomorrow's sessions. It will be very good. And yes, I assume now, sir, that nobody has any questions, so everything is understood. And yes, my request is try to install this Ansys software as early as possible, just for your benefit. So if I am giving like these lectures and after like maybe 1 or 2 months, if you are not practicing by yourself, I think, and if you do not have these videos available, you might, you can't remember at that. You are learning this first time, so I suggest to have some practice. And yeah, kindly install Ansys as early as possible. And I think Ajay, he is also sharing these videos with you after our sessions. So there is no big deal, but yeah, try to get it installed as early as possible. Okay, then I conclude for the today. Let's meet tomorrow again at the same time. Then I wish you all a good night.
Thank you, sir.
Thank you,
Thank you
sir.
all of you. Bye.